Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about graphing a quadratic function from intercept form. So we did talk about graphing quadratic functions in standard form and also in vertex form. You can go back and listen to those two videos if you want some detail on how to graph from those two forms. Today we're just talking about intercept form. Call it intercept form because intercept form gives us the x-intercepts, and the intercept form is y is equal to a times x minus p times x minus q, where these are the quadratic factors of the quadratic in standard form. All right, so intercept form y is equal to a times x minus p times x minus q. The x-intercepts are going to be p and q. So I'm going to give you here a quadratic in intercept form. Y is equal to x plus 4 times x minus 2. And your x-intercepts are negative 4, 0, and 2, 0. All right, from the x-intercepts, we can find the axis of symmetry. From the axis of symmetry, we can find the vertex. All right, so just to give a graphic here, rough graphic, I'm going to identify the x-intercepts 2 and 4, and then we're going to use what we know about the axis of symmetry. It goes right between or splits the two x-intercepts in half, so to speak. So what we need to do is find the midpoint of the two x-intercepts, the x values, and then we'll find out the x value for the axis symmetry. So our two x-intercepts are negative 4, 0, and 2, 0. Negative 4 plus 2 divided by 2 to get the midpoint is equal to negative 1. So negative 1, 0 is our midpoint, but we only need the x portion of it, so x is equal to negative 1 ends up being our axis of symmetry. All right, so now we're going to use the axis of symmetry to find the vertex. We're going to substitute x, or x is equal to 1, into the value for x in our intercept. So here we substitute the value of negative 1, and then we're going to solve for y. Negative 1 plus 4 times negative 1 times minus 2. Excuse me, negative 1 plus 4 times negative 1 minus 2 leaves us with 3 times negative 3, which ends up being negative 9. So our vertex is negative 1, negative 9. All right, and lastly, we're going to find the y-intercept. To find the y-intercept, we set x equal to 0. We're going to substitute 0 in for x here, and then solve 0 plus 4 is 4. 0 minus 2 is negative 2. 4 times negative 2 is negative 8. And our y-intercept is 0, negative 8. All right, so we're going to use those values to graph our function. Negative 4, 0, 2, 0. X-intercepts, that's what we got. Negative 1, negative 9 for our vertex. Should be a 9 here. 0, negative 8 is our y-intercept. All right, so let's take care of one more. I'm going to give you the function in intercept form. You can do the work, and then we'll come back and check it. So I'll give you a moment to do your work. Pause here, and you come back and let's check your work. All right, so x-intercepts p 0 and q 0, negative 2, 0, and 6, 0 are our x-intercepts. We're going to use that to find the axis symmetry using the midpoint formula just for x. 6 minus 2 divided by 2. 6 minus 2 is 4. 4 divided by 2 is 2. X is equal to 2 is our axis of symmetry. We're going to use that information to find the vertex, substituting 2 into the function. 3 times 2 plus 2 times 2 minus 6 gives us 3 times 4 times minus 4. Negative 16 times 3, negative 48. 2 is the value for x. Negative 48 is the output for y. That's our vertex, 2, negative 8. Now we're going to solve for the y-intercept. We're going to set x equal to 0. 0 plus 2 is 2. 0 minus 6 is negative 6. 2 times negative 6 is negative 12 times 3, negative 36. 0, negative 36 is our y-intercept. All right, now we're going to graph 2, negative 48, 0, negative 36 for our y-intercept, 2, negative 48 for our vertex, 2, 0, and 6, 0 for our x-intercepts. All right, that's it for this edition of Otten Math. We've covered standard form, vertex form. Now in this particular video, intercept form. Come and join us next time when we talk about how to create equations for parabolas given 2 points on the graph.